So as you can see, this evening I'm going to talk about the Christian origins of modern science, and I'm going to have two main sections. The first one I want simply to reflect about what it is to give a historical explanation for the origins of something like science. And then I'm going to give you a number of options for how Christianity had an influence on the modern science that we know about today. So let me start by talking about historical explanation. When historians posit a particular cause for something that happens in history, unlike scientists, we don't have the luxury of running an experiment in the laboratory and isolating the relevant variables, okay? We can't actually do that. So how then do we decide what factors were crucial in the emergence of particular historical phenomena? I'm going to change tack here for 1 second, as you can see. It's about 20 hours flying time from Australia to here, and when I make these trips I usually put something on the iPad just in case the in-flight entertainment is not working, and my choice for this trip was The Man in the High Castle. I've only, I must confess, got as far as the first episode of the first series, but so there won't be any plot spoilers this evening, but I can tell you here is the fascinating premise of this series, and that it's that the course of history went differently to the course that we know, and the good guys lost the Second World War, and so Japan occupies the western half of the United States, and Nazi Germany occupies the eastern half. That's the premise. Now, what we have here is an example of a counterfactual history. And counterfactual history is one of the ways in which historians can think about alternative futures and how the path of history might have been different had something in the past changed. So it's an imaginative way about thinking, what are the variables that led to the present that we now occupy as opposed to some alternative present, as, for example, if the Axis powers had won the Second World War. And I was interested to see, actually, what I would be interested to see would be my notes, which I thought I'd put up here, but which I think Ken may well have taken, because I thanks. Because I just ran out of things to say right at that moment, and I thought, okay. Yeah. Thanks, Ken. It was a nice test, and I clearly have failed it. But we actually had two references in each of the talks this afternoon to other forms of counterfactual reasoning, so I'm just going to digress about those for a moment. Michael Murray mentioned the condemnations of 1277 when certain propositions of Aristotelian philosophy that were taught in the University of Paris were condemned. Article 49 of those propositions, depending on how they're numbered, but in one particular version of the numbering, is this: that God could not move the universe rectilinearly in a particular direction, because if he did, that would leave a vacuum. Now, Aristotle had taught there's no such thing as a vacuum, and therefore the argument was God would not be able to move the universe sideways. And that was an article that was condemned, because it was argued that God, in his omnipotence, could actually perform that act. There was no reason why he could not. And Michael also made reference to the fact that for some people, for some historians, these condemnations of 1277 actually had a significant influence on the development of modern science. And I think they're right, because what they enabled people to do was to imagine counterfactual situations that never actually eventuated in empirical reality. That thinking in terms of divine omnipotence and what was possible for God enabled people to think about imaginary scenarios. For example, if we think about the law that says an object that is in motion will remain in motion unless it is acted upon by a force, that is something that you never actually see. Everything that we see in the world that is in motion will come to rest at some point if it is not acted on by something like an engine. And certainly the objects that we see in the heavens operate under different principles. But the point here is that when we get to the modern science of the 17th century, it's actually being able to imagine things operating in a frictionless world, or in the case of dropping objects, in a world where there's no atmosphere, so that the feather will fall at the same acceleration as the lead weight. These are things that only can happen in our imagination. And the Aristotelian world, that this new scientific world brought to an end, is a world where these impossible things were actually posited as laws of nature. So counterfactual thinking turns out to be quite important for modern science, and hence the 1277 condemnations help people to do that. The other example was in Ted's lecture, where he spoke about the claim that both Bellarmine and Barberini had made to Galileo, which was this: that God could have arranged the heavens to be moving in this fashion in any number of ways that we cannot conceive of. And for Galileo to say he had got the exact mechanisms right was completely presumptuous. And I think this is a really important scientific principle, that it's known formally in the philosophy of science as the underdetermination of data by the evidence. The point for us is, though, that whatever we observe in the world, there could be mechanisms that bring it about that we haven't thought of. There could be ways that the phenomena we see happen, and while one model might give us excellent match to the phenomena and excellent predictions too, that doesn't make it true. Because in the case of Galileo, we had three competing models of how things were moving in the heavens, each of which were more or less empirically equivalent. Okay? And this was the point that was being made to Galileo, that there are a range of possible models that give us the appearances that we see. And therefore, counterfactually, there might be unforeseen arrangements that we have never thought of. So I just add that in. So do I get an extra 2 minutes, I hope, but I'm going to press on. Here's another really interesting counterfactual scenario that is more relevant to my talk. Philip Pullman produced a trilogy called His Dark Materials, based on the fascinating premise of a future that is unlike ours. And that future came about, he argues, at least in the first volume, because the Protestant Reformation never happened. And what's interesting about this world is that something like the Catholic Church, the magisterium, is still running the show. Do they have science? Yes, they do have science, but as you can see by the technological devices that we have there, it was a science that is a bit different from our modern science. And I think Pullman is exactly right, in this respect at least, that had the Protestant Reformation never happened, that religious revolution that took place in roughly the 17th century, we would have had science, but we would have had a science, I think, that was rather different to the science that we have now. And crucially, we would have a science that may not be as prominent an enterprise as science currently is in our present society. So here's another way in which counterfactual reasoning about an alternative future can help us think about what are the actual causes in history that give us the present that we actually inhabit today. Now, fortunately, historians have more to rely on than just imagining counterfactuals. We also have other cultures that didn't have scientific revolutions, and by comparing those cultures to our cultures, and our culture, Western culture I mean, and the differences between them, we can then think about what the relevant variables are. And for historians of science, the three comparative cases are these: ancient Greece, medieval Islam, and China. Now, what's significant, I think, about this comparison is it's not that these cultures didn't have science. They did have science. But science did not take off. Science did not consolidate. Science did not grow. So part of what we have to explain as historians is not merely the origins of science or the origins of a scientific culture, but why science persists. And in the case of the West, why science moves to the centre of the culture and becomes the dominant model for pretty much everything. Okay? And just to give you an example, I think China is perhaps the best case here. China in the 17th century was technologically ahead of the rest of the world, and yet the West eventually overtook it. Voltaire makes this very interesting remark about how sophisticated China is. The point I want to make, and this will come to one mode of explanation, is that it's not just about the ability to do science, it's about valuing science, it's about the values that underpin science, it's about sociologically what we call social legitimation that is key to having science being a prominent part of your culture. So if you think of the joke about the definition of a gentleman, the gentleman being the person who can play the accordion but doesn't, and insert your own instrument of choice there. I've heard bagpipes, the banjo, even something relatively inoffensive like the trombone. But anyway, in a sense, China had the capacity to make science big if they wanted it, but they chose not to, right? They chose to focus on more humanistic pursuits, right? In the West, for some reason, in the 17th century, we both had the capacity to do science and we backed it. And that then is a question not merely of the origins of scientific practice and scientific theory and scientific ideas, but it's about coming up with a set of values that say, we're going to pursue this at the cost of other kinds of cultural activities that you might say are equally valuable, all right? And it's a question we tend not to ask ourselves today because the benefits of science just seem obvious, but they weren't obvious in the 17th century, and I'll give you some examples later. Okay, so that goes to our modes of explanation. We're not just going to explain the origins of science, but what are the values that underpin it, that give it social legitimacy and that give it legs. Now, I'm going to give you some alternative versions of history before I get to the true version, which is the one that I'm going to give you. But here is a very common view of the relationship between Christianity and science. And this is a graph that you will find on a website called nobeliefs.com. And the clue, I think, is in the title. Now, this is a very spurious graph. I'm not sure what the units of scientific advancement on the y-axis are, whether they're metric or imperial, because I know you guys are very big on imperial units of measurement for reasons that me nor the rest of the world understands. But anyway, we can go over that in the Q&A if you like. But here, the argument goes something like this. Science was going along quite happily, and then Christianity happened, and it slumped throughout the whole Dark Ages. And what made science possible, the scientific revolution, where we see the big red exponential leap, is that science breaks away from Christianity. And it's its breaking away from Christianity that makes its successes possible. And Galileo is usually a key exemplary figure in this breakaway. We also get a version of this in the original cosmos, or however you guys pronounce it, slightly differently to that, I think. And we're going from the top down here. So we have lots of science happening. The ancient Greeks are up to their eyeballs in science. But then the Christians come along, and according to Carl Sagan, we have the destruction of the Alexandrian library by the Christians in about the year 400. Well, he's out by about 400 years because it was actually Julius Caesar's legions who started the fire in the Alexandrian library, and it sort of was on the decline ever since after that. But again, we have this gap theory about Christianity is the thing that puts the kibosh on the emergence of modern science. And what I'm going to suggest this evening is that that theory has it actually completely wrong. That what gave science the boost in the 17th century was not its separating away from religion, but actually by there being a closer relationship between science and religion than there had been throughout the Middle Ages. And I don't want to argue here that the Middle Ages were backward and unscientific. On the contrary, we know that's not the case. But it's very interesting that in the Middle Ages, the sciences, natural philosophy was practiced in the undergraduate area of the undergraduate faculty of the university, and theology was one of the higher faculties, and they were quite distinct and quite discrete. Indeed, one of Galileo's problems was that he sought to combine science and theology. Okay? So, bear that in mind. What I'm going to be arguing this evening is that what gives science a boost in the 17th century is a closer relationship between science and Christianity than what we see in the Middle Ages. Where does this odd view about history come from? Essentially, in a nutshell, it comes from Enlightenment thinkers. One example, Condorcet. Here's the historical argument that Christianity was the cause of the stagnation of the sciences. Okay? So this view about a conflict between science and religion, or the idea that Christianity had a stifling influence on science and its emergence, is actually a theory of history that we see associated with Enlightenment thinkers like this guy. And there's another Enlightenment theory of history that I'm going to give you in a moment, because it comes from we can see it in the second version of Cosmos, Neil deGrasse Tyson's version of Cosmos. In episode 3, he talks about when knowledge conquered fear. And Isaac Newton is his exemplar here. And the argument goes something like this: human beings were in their infancy. They had these idle religious explanations of what was going on in the heavens, and then along came Newton, and he gave a grown-up scientific explanation of what was going on in the heavens. And so the view of history that we have here is a progression from a kind of infantile, religious, fear-ridden view to a sophisticated, rational, scientific view. Again, we go back to, it's these French guys who are the problem. Auguste Comte, who has a theory about the progress of history, that we go from a religious phase through a metaphysical stage, and then we get to the scientific stage. So if this is your view of how it works, that science and religion are inherently in conflict with each other, or that religion is a kind of primitive stage that we're destined ultimately through some inevitable historical process to overcome and grow out of, then inevitably you're going to think that Christianity is not contributing to science, but rather Christianity is either opposed to science, or Christianity is something that we grow out of when we become genuinely scientific. So, what is wrong with this picture? Well, here then I'm going to talk about these modes of religious influence, and I'm going to speak very briefly about motivations, and I'll say a lot more about presuppositions, methods, and social and moral legitimation. So let's start with motivations, and this is a very simple one. That key figures during the scientific revolution were motivated by religious considerations to practice the science that they did, and I'll give you two examples of people who were clearly motivated by their Christian convictions. Johannes Kepler, and you can read what he's saying here, and Robert Boyle underneath. Johannes Kepler, it's interesting, historians aren't here, we don't like giving out prizes in the past, but Galileo is the guy who often gets the prize for being the gun astronomer in the early modern period. I actually think Kepler is more important for the development of modern science. Okay, I think Kepler's more important. And here is Kepler making this interesting vocational statement. And again, Protestant notions of vocation turn out to be quite important for giving science a boost, because Kepler wants to say, I wanted to be a theologian. Kepler is a Lutheran, but now I understand that studying nature as an astronomer is also a way to kind of do theology. So I see how God is praised by my work in astronomy. And this goes to, as I said, partly a Protestant idea that mundane vocations are also important callings. It's not just the priestly vocation, that is the theological one. And it becomes possible in the 17th century for the first time to practice natural philosophy in a theological register. Again, bringing these together where once they were largely separate. Here's Robert Boyle, again, a similar theme. I'll say more about Kepler's achievements in a moment. Robert Boyle, we have one of the world's Boyle experts sitting right here, so I'm reticent to say too much about Boyle. But Boyle is really a key figure in the emergence of experimental science in the 17th century. And here's what he's saying: discovering unto others the perfections of God in the creatures is a more acceptable form of religion than the burning of sacrifices or perfumes. There's a biblical reference here. Boyle will later talk about rational religion or genuine religion and scientific practice as being a form of true or genuine religion. So he sees this as an intrinsically religious activity to be engaged in scientific practice. Now, I would say that not all early modern figures have this level of devotion and motivation. So people like Descartes, for example, who did make very important contributions to early modern science, speaks much less about his religious motivations, but many people at the time, Newton, of course, will be another example, clearly have religious motivations in their pursuit of science. So I said I'm going to skip through that fairly quickly and move on to presuppositions. And here we want to say, what is it that you have to believe to be the case before science becomes possible as an enterprise? And the one aspect of presuppositions that I want to talk about this evening is the modern idea of laws of nature. Now, up until the emergence of modern science in the 17th century, the science that was practiced, or the natural philosophy as it was then known, was essentially Aristotelian. So Thomas Aquinas and the gang won that battle. Aristotle was baptised, Aristotle's works became the undergraduate curriculum in the universities. And what was Aristotle's conception of how things happen in the natural world? Well, in essence, for Aristotle, and indeed for Christianised versions of Aristotle, things in the natural world operated according to inner powers and qualities that they had. That's what moved them around. So if I were to drop this it would move that way. Why? Because this has an inherent capacity to move to its natural place of rest, which is the centre of the earth. Okay? This is why we needed a whole new physics before we could get a Copernican view up and running. Okay? And that whole new physics didn't come with Galileo, it only came with Newton. But what makes this thing move is its inherent qualities or powers. That was the Aristotelian view. Okay? And indeed, this applies to anthropology too, that human beings then, under this scheme, have a natural desire for God and they move. This is the famous, it's referenced in the famous quote of Augustine in the opening sections of the Confessions. Our hearts are restless until they find their rest in you. There's an implicit physics there, right? That the inherent desire of the person is for God, just as the inherent desire of this is to move towards its natural place. So that the overturning of this Aristotelian physics actually has important religious implications, but I won't be going into any of those tonight. 17th century, we have a totally different view about how this works, and things are moved not by their inherent capacities, but they're moved because God imposes directly on them laws of nature, and that's the only way in which they move. Now here's one example, Kepler. And that slightly obscure diagram that you can see there is a representation of Kepler's 3 laws of planetary motion. And of course you all know these. The first one is that planets move around the sun in an elliptical path with the sun at one of the foci. The second law is that planets will, as they move in their elliptical orbits, A1 and A2, in equal times, the area under the curve is equal, right? Equal areas under the curve. And the third one gets more complicated. The square of the period, the time the planet takes to orbit around the sun, is proportional to the cube of the axis of orbit. Now, why? Why do the planets follow these geometrical patterns? For Kepler, it's because God is a geometer and decided to impose these geometric relations on the world. And Kepler says that explicitly, right? This is why the planets conform to these formulae, because God is a mathematician and God instantiated these mathematical laws on the planets. We next move to Descartes. Kepler, interestingly, Ted has just pointed out to me today that Kepler does have this language of laws of nature. Nomos, what does it remind me, Ted?
He called it leges corporis.
Okay, so it's Latin, right, leges. Yeah.
Or
Okay, leges, so laws of matter or laws of bodies, right? So you do have that. But Descartes' the first guy to come up with the notion, a very coherent notion of laws of nature. It's interesting that Kepler didn't call those laws of nature. We call them the planetary laws, but he came up with the relations. But here's Descartes, which is a very interesting expression here. So you can read it for yourselves, but I'll read it anyway. God imparted various motions to the parts of matter when he first created them. He now preserves all this matter in the same way, by the same process by which he originally created it. So the distinction, the theological distinction, creatio ex nihilo, creatio continuo, Descartes says they're one and the same thing. So, okay, so here's this again. What is it under Descartes' law that makes this go like that? What it is for Descartes is that this has no inherent capacities whatsoever. The only thing that makes this move is that God successively recreates it in different positions until it gets down to there, right? The earth has no capacity, that has no capacity. The only causal power that's operating is God, and God, because he's immutable, the laws of nature are immutable and unchanging, and because God is omnipotent, these laws are universal, right? So the laws of nature derive their universality from the fact that God is their direct author. And this then becomes the conception of laws of nature that the guys over the channel, Boyle and Newton and Samuel Clarke, who I'll talk about in a moment, this is a conception of laws of nature that they will adopt. So the whole presupposition of modern science that says we have a physics that's based on laws of nature is ultimately theological in its origin. God is doing the work, and he's doing it according to a certain set of geometrical patterns. Okay? Let me give you Boyle. And we'll try again. There he is. So here is the laws of motion don't spring from the nature of matter. That was the Aristotelian idea. They're not inherent in things, but they depend on the will of the divine author of things. So it's God's will that moves things around. That's why they move in the way that they do. So what follows from this then is the conclusion, the course of nature then. What is the course of nature or the way the natural world operates? It's nothing else but the arbitrary will and pleasure of God exerting itself on matter continually. Okay, so that's the Descartes idea, that it's God's continuous recreation of things moment by moment according to the laws that God has imposed on them. Well, that's Samuel Clarke, by the way. Who was Samuel Clarke? Samuel Clarke, he's a bit of an underrated figure these days. He's probably the most sophisticated philosophical theologian of the 18th century, but he is a key apologist for Newton. So he's the guy who does all of the theological work on Newtonian philosophy and famously takes up the battle with Leibniz. Newton and Leibniz had this controversy, and Clarke is the guy who takes the Newtonian position. There's a famous exchange called the Clarke-Leibniz correspondence, because these guys disagreed. But Newton's masterwork, the Principia, if we look at the preface to the second edition, Newton, as it turns out, didn't actually write the preface. Roger Coates, who actually co-authored a fair bit of this, helped him out with it. But you can see here, again, the same notion. The business of true philosophy, by that he means natural philosophy, which we understand now as science, is to inquire after the laws that the great Creator actually chose to found this most beautiful frame of the world, not those by which he might have done the same had he so pleased. Now, what's at stake here? You probably don't need to know this, but I'm going to tell you anyway. There's a bit of a controversy between Descartes and Newton, because Descartes had a very speculative view about what makes things move around up there in the heavens. And well, let me tell you Newton's. Well, we know Newton's view, right? It's gravity, and it's making this stuff move around. But what Newton wants to say is we can imagine all kinds of things, and this goes to the underdetermination of the data by the theory, right? Which is to say there are a lot of ways we can explain that stuff up there. You have to test it and do experiments. And Newton very cleverly found ways to do terrestrial experiments that confirmed what was happening in the heavens. Part of this, of course, meant collapsing celestial mechanics and terrestrial mechanics, which again, Aristotle had these two quite different. Stuff up there moves eternally in circles, and stuff down here moves in straight lines and stops. Now Newton says, actually, same principles apply. You just have to think counterfactually about what's happening on Earth. Okay? So, Descartes' theory, incidentally, and Descartes has this invisible fluid, and for him the planet's moving around. It's like stuff getting carried around when you pull the plug out of the drain and it goes like that. That's his theory. Sounds crazy, but what Newton has to make happen is spooky action at a distance, right? So Newton is postulating planets moving, hasn't got an explanation for how it's happening. Has no physical, mechanical explanation. So you often hear talk about the mechanical worldview. Newton is not a mechanist. He can't be. He doesn't actually have a mechanism to get the planets in motion, except it's God actually doing it. Right? That's it, in a nutshell. Newton wanted to avoid this conclusion. He did attempt to come up with some mechanistic explanations, but in the end had to say, or at least through Bentley, the first Boyle lecture, that gravity is God. That was the short version of it. Okay, let me give you Samuel Clarke once more, because he'll sum it up, and then I'll move on from laws of nature. So what it means is that, for Clarke, absolutely speaking then, nothing is actually miraculous if we have respect to the power of God. It's about our own understanding. Just about everything that we call natural as what we call supernatural, in the same sense, is really miraculous. It's only the unusualness or usualness that make the distinction. Consequently, there's no such thing as the course of nature or the power of nature. Nature has no powers at all. It is a continual miracle. That was the bit that Leibniz objected to, right? But this was the Newtonian view. Everything that happens is miraculous. It's just that the unusual ones we label, from our perspective, miraculous. But all of these laws of nature are utterly miraculous, and the whole premise of modern science is that there's this continual miracle going on as God moves stuff around. Now, there's an interesting story of how we move away from that conception. In the 19th century, the valence flicks, and if God's doing it all, they just say, well, he might as well be not doing anything, and we're going to put all those powers back into nature, right? But that's another. I'm a 17th century person, so I'm not going to talk about the 19th century. You'll hear about that tomorrow from Ted. Okay, so there's one example of how presuppositions are key to, Christian presuppositions are key to understanding the operations of nature. And what we also see importantly is that Kepler and Boyle and Newton are all doing theology, and this was the difference between this period and the medieval period, when the practice of natural philosophy and the practice of theology were quite separate. And this instances the coming together of theology and science in a way that they were actually separate in the Middle Ages, but in a way that makes possible this boost that we call the scientific revolution. Now, methods. This is going to be hard work for an after-dinner talk, I'm afraid, but I'll take you through it. But this basically is, I'll give you in 5 minutes what's in this book, right? So we'll see how we go. And here the argument is that actually theological anthropology, theological theories of the person, are going to inform the methods of science, and particularly experiment. Here's Luther and Calvin on the fall. Okay, so what's Luther saying? People like Aristotle, the philosophers, they didn't know anything about the corruption of human nature. That's what he's saying in that first paragraph. So they were smart, right? But they didn't know that. And the second part, interestingly, is about Aquinas and the medieval thinkers. Because on the reformers' view, Aristotle didn't know anything about the fall, and the medieval Aristotelians knew about the fall, but they didn't stress its consequences enough. So they thought, and here's the technical version of it, they thought that the fall took away supernatural powers that human beings had, but the natural powers remained. And what Calvin wants to argue is that the fall affected all of the powers that human beings had. And that's what the doctrine of total depravity is about. So it's not just an extreme version of depravity. It's that depravity affects every single part of the person. And what follows from that for Calvin, and indeed for Luther, is that it's not merely our moral capacities that are wounded by the fall, but our epistemological capacities, our capacities to know, right? They are damaged by the fall too. And that will have implications for science. Now, what's Aristotelian science like? It's based on common sense observations of the natural world. So we see things in motion come to a stop. We see things fall to what looks like their natural place. The feather doesn't fall as fast as the lead weight. Common sense, we generalise, right? What these guys are going to say as a consequence of the fall is you can't actually make generalisations on the basis of common sense anymore because our senses and our reason systematically deceive us. So there's the Luther quote. It's impossible that nature could be understood by human reason after the fall. So the whole of Aristotelian science was premised on a mistake that was perfectly understandable. Aristotle didn't know about the fall. He thought our reason and senses could be relied upon. Says Luther and Calvin they can't be. Let me give you long text here, sorry about that, but a long quote from Pascal. He's saying the same thing. And he goes to two opposite extremes. If you read the quote, in essence he's saying the ancient philosophers were either like Aristotle, they were too optimistic, thought we could know things really easily, or they fell into the other extreme and they became skeptics, right? And say you can't know anything at all, right? There were two ancient schools of skepticism. One that said you can't know anything at all, they were the academic skeptics, and then there were Pyrrhonic skeptics who said to the academic skeptics, you can't even know that. So, not sure who was more sceptical, but anyway, skepticism got a bit of a run then in the early modern period as well. And Pascal wants to say human beings have a sense of what is possible, but their fallen condition makes it difficult for them ever to achieve it. So they have a scientific desire, they have a curiosity and a thirst for knowledge, but sadly they lack the capacity to actually to achieve it. So that's why we perceive an image of truth. We still have that, right? But we're incapable of both ignorance and knowledge. So we were once perfect in the Garden of Eden. Adam had a perfect encyclopedic knowledge. That was the view in the 17th century. But we have fallen away from that. That's actually a key passage because part of what's going to motivate modern science is an attempt to recapture what was now understood to have been lost as a consequence of the fall. And we see that in one of the guys who was probably the most important theorist of experimental philosophy in the early modern period, and that's Francis Bacon. So here he says, here's the fall stuff coming through. The human intellect, left to its own devices, is just not to be trusted. Okay? It's deceitful. And so how do we make our way through the uncertain light of sense? What's the goal of this new science? to see whether the great commerce between the mind of man and the nature of things, and this is more precious than anything on the earth, or at least anything that is on the earth, might be any means restored to its perfect and original condition, and if it can't be restored to its original condition, whether it might be reduced to a better condition than it presently is. So the idea of the fall, which the Protestant reformers now emphasise much more strongly than their medieval counterparts had, it feeds into religious thinking in England, and someone like Francis Bacon can now say we've fallen away from our original condition. We can't rely on reason, as Aristotle did. We can't rely on the senses either, unless we do something with them. But we do want to get back to our prelapsarian, pre-fallen condition when Adam had dominion over nature and mastery over nature. We need to recover that dominion. And how do we do that? We do that through the new science. And then there are both as we'll see, some of the hints about why we need to do experiment, but also the values that will underpin modern science. The fall narrative is kind of summed up in this famous book by Robert Hooke, first curator of experiments of the Royal Society, the guy who probably came up with the inverse square law about the same time as Newton, although Newton and he didn't get on. He's a very important key figure. This beautiful book has got drawings of things that he looked at under the microscope. So if you ever get a chance, you can look it up online, Micrographia. Beautiful drawings. But here it is. This is really a summary of the argument that I've been giving you. Every man, both from a derived condition innate and born within him, derived corruption, innate and born within him, and from commerce and breeding and commerce with other men, will slip into all sorts of errors. Because of the fall, we're prone to mistakes. These are the dangers in the processes of human reasoning. The remedies of them all can only proceed from the real, the mechanical, the experimental philosophy, which is to say experimental science, not Aristotelian science. Experimental science is the way that we overcome the losses of the fall. Okay, very quickly, what are the characteristics of experiment? Our knowledge is probabilistic. Aristotle, the scientific ideal for Aristotle was demonstrable knowledge. And we heard about demonstration this afternoon. This was Galileo's problem. He didn't have a demonstration. And that was the only conditions under which your claim could be set against what's in the Bible. We have knowledge of phenomena, not essences. Aristotle said to know things, you have to know their essence. Experimental philosophy, forget essence talk. There aren't any essences. All you've got are the appearances of things. Crucially, knowledge is corporate and cumulative. You need lots and lots of people doing science. It's not just some guy theorising. It's not the lone genius. You need lots of people, like something like the Royal Society. Has to be sponsored. And it's cumulative, it's long term. You build up knowledge over time. People add little bits in. It's experimental, which is to say it's based on the senses. Experimental in the 17th century just means experiential, based on experience. It's not speculative, based on reason. Because our senses have fallen, Adam was said by most of these guys to have had telescopic vision, and he, like Superman, right? He could actually see what was happening in the heavens. We can't. What we do have, though, are telescopes and microscopes. And that actually restores some of the kind of capacities that Adam had in his pre-fallen state. Nature itself has fallen, and therefore we need to investigate it aggressively and experimentally to make it subserve to our purposes, as Bacon would say. And this method then is kind of a therapeutic regimen that's designed, the whole thing is designed to overcome the limitations that arose as a consequence of the fall. Okay, that's the quick and dirty version of how Reformed theological anthropology feeds into experimental science or experimental natural philosophy. Much longer story, but that'll do for now. Last one. Okay, the slide here was supposed to say social legitimation and presuppositions. But here I come to the point that it's not just about the origins of science, it's about valuing science and wanting to do it and wanting to value it. And again here, it's Christian values that underpin science in its infancy in the 17th century and give it that consolidation that gets past the boom-bust patterns that we see in comparative cultures. So we have a boom-bust pattern in China, in medieval Islam, in ancient Greece. Little flurry of scientific activity, nothing much happens, people get on with other things. In the West, little flurry of scientific activity, it consolidates, it grows, it becomes huge. And that's where we're at today. And Thomas Babington Macaulay, I think, gets it right. Here's what the problem was before Bacon. The ancient philosophy disdained to be useful. It was content to be stationary. It dealt largely with theories of moral perfection. Now, that's a bit of an overstatement, but the point here is that philosophy, including natural philosophy or science, were primarily, from the ancients right up to the 17th century, about the formation of the individual. That was the primary thing. So scientia was a virtue, and the practice of science was to perform work upon yourself. Anything else out there that happened to be useful was a byproduct. But as Babington Macaulay's got it exactly right. It's about theories of moral perfection or moral formation, okay? And it's interesting that in the 17th century there's still argument about what is the more noble course of action, things that deal with the moral perfection of the individual or things that deal with the mastery of nature. And people like Boyle, interestingly, are trying to argue that it's both. And all of the defences of the Royal Society against criticisms, because people thought all this utilitarian stuff, it's not as important as moral formation, right? So there's criticisms of the new science. We see this in Jonathan Swift's Gulliver's Travels, where he lampoons the activities of the Royal Society. Useless. Useless in what sense? Useless for the moral formation of the individual. But now, the moral formation of the individual is not important. It's the mastery of nature that becomes important, and Babington Macaulay is applauding this shift. How does it come about? How do we get to change this? Because the mastery of nature gets its own religious legitimation at first. And Bacon is the guy who sets it up, or at least expresses it. So knowledge then, he says, is to be sought not for the quiet of resolution, not for the contemplative life, but for a restitution and reinvesting of man to the sovereignty and power that he had in his first state of creation. So the big impulse to do experimental science is to redeem what was lost as a consequence of the fall way back in Eden. So there's the big religious story. It's part of redemption to re-establish control over nature. And that's where science, in its infancy, in 17th century England at least, gets its moral legitimacy. So, just a couple more slides and then we'll wrap it up. Here is, again, I think, the sentence in Bacon, Francis Bacon, that really sums up this whole notion about the fall re-establishing our lost power over nature as the justification for pursuing science. So man by the fall fell at the same time from his state of innocence and from his dominion over creation. Our state of innocence can be repaired by religion, but our dominion over nature needs to be repaired by the practices of science. And so we need to subdue nature to serve our purposes as it once did in that pre-Edenic state. So there's one key set of values that gives science an impulse and a boost in the 17th century. There's one other one which is more obvious, and I'll give you that one now, and then we'll wrap up. And that is, hinted at already in the motivations, that the study of the scientific study of the natural world gives us evidence of God's power and wisdom. So here are Boyle and Newton. Rational contemplation of nature is a philosophical worship of God. That's why we practice science. It's a kind of worship. And then Newton is giving us this example of what we now call natural theology. That is, that the study of nature gives us evidence for God's work in the world and God's government of all things. So, wrapping things up, you might hear it said that science and religion are in perennial opposition. You might have heard it said that Christianity was a barrier, it's consistently been a barrier to science and its emergence. That story has got it completely the wrong way round. If we were imagining alternative futures or alternative cultures, I think I can say with a reasonable degree of confidence that were it not for the particular Christian milieu of the 17th century, we would not have science in the form in which we have it, and neither would we have a science that has the great legitimacy that it presently has. And let me stop there.